Electromagnetism is the study of the effects of electric charges both at rest and in motion. Charges are the source of an electric field. Charges come in two types, positive and negative. The electromagnetic force is one of the four fundamental forces of nature. It is the main binding force of the atom outside the nucleus. The electromagnetic theory is important to understanding nature. Charge is the property of subatomic particles that gives rise to electric fields. The charge of a particle can be negative, positive, or neutral. It's a fundamental property of matter. This is an illustration of a positive electric charge. The field lines are always depicted as heading away from a positive charge. This is purely a convention of the electromagnetic model. It is based on the direction of a positive charge in the field. This is an illustration of a negative electric charge. Field lines are always depicted as heading into the negative charge. This is purely a convention of the electromagnetic model. It is based on the direction of a positive charge moving in the field. Put two positive charges together, and the force lines repel each other, heading away from the other charge. This results in the two positive charges repelling each other. Put two negative charges together, and the force lines repel each other, bending away from the other charge, resulting in the two negative charges repelling each other. Put a negative and positive charge together, and the force lines bend in towards the opposite charge, resulting in the negative and positive charges attracting each other. This is the case for charges that are at rest with respect to each other. That is, they are not moving relative to each other. When charges are moving relative to each other, magnetic fields come into play. Magnetism is the force of attraction or repulsion resulting from the motion of electric charges. While the force lines associated with electric charges tend to be straight, magnetic force lines tend to be circular. This is an illustration of the magnetic field around a cylindrical magnet. Note that there are two poles instead of one. The magnetic force lines are depicted as going from north-south in a circular pattern. This is an illustration of the magnetic field around anti-parallel cylindrical magnet. Note that each magnet has two poles and that the magnetic force lines are depicted as going between the two magnets from a north pole to a south pole in a circular pattern. As a result, the two magnets are attracted to each other. This is an illustration of the magnetic field around two cylindrical magnets oriented end to end and north pole to south pole. Note that each magnet has two poles and that the magnetic force lines are depicted as going between the two magnets from north pole to south pole in a circular pattern. As a result, the two magnets are attracted to each other. This is an illustration of the magnetic field around two cylindrical magnets oriented end to end and north pole to north pole. Note that each of the magnets has two poles. The magnetic force lines are depicted as going from north pole to south pole of each magnet in a circular pattern. However, they are repelling the force lines of the other magnet. As a result, the two magnets are repelling each other. This is an illustration of the magnetic field around two parallel cylindrical magnets. Note that each magnet has two poles, and that the magnetic force lines are depicted as going from the north pole to the south pole of each magnet in a circular pattern. However, they are repelling the force lines of the other magnet. As a result, the two magnets are repelling each other. Magnetism is seen naturally in certain rare earth minerals. Ferromagnetic metals such as iron can be artificially magnetized. The Earth has its own magnetic field, as do the planets Mercury, Jupiter, Saturn, Uranus, and Neptune. The tendency of natural magnets to point north, when allowed to turn freely, helped lead to the discovery of magnetism. The other was their ability to pick up metal objects. However, the fields of permanent magnets cannot be controlled. Electrodynamics is the branch of physics dealing with the electromagnetic forces between electric charges. In its most basic form, electrodynamics deals with the effect of charges in relative motion. When an electric field is not in relative motion, it is just the electric field. When this electric field is placed in relative motion, the result is a magnetic field at right angles to both the electric field and the relative motion. Furthermore, when a magnetic field is in relative motion, it will in turn produce an electric field, also at 90 degrees to both the magnetic field and the direction of relative motion, as shown in the illustration. The common way of determining field direction is called the right-hand rule. It shows up several times in the field of electromagnetism. Hold out your hand as shown here with the three fingers pointed at right angles to each other. The three field vectors point as illustrated. The velocity vector points in the direction of the thumb, the magnetic field points in the direction of the index finger, and the electric field points in the direction of the middle finger. This forms the unification basis of electric and magnetic field. Everything else in electromagnetism extends from these starting principles. An electromagnet is a magnet whose magnetic field is produced by way of an electric current. The magnetic field exists only as long as the current is flowing. The magnetic field ceases to exist when the electric current is turned on. An electromagnet starts with a wire. Introduce an electric current into the wire flowing in the direction of the arrow. The flow of the current produces a magnetic field, even though the wire remains electrically neutral. This is where the right-hand rule comes into play. Point your thumb in the direction of the current. Wrap your hand around the wire, as shown. The magnetic field points in the direction your fingers are pointing. When the wire is bent into a loop, it produces a dipole magnetic field. When the loop is repeated several times, the result is a stronger electromagnet. Putting a piece of iron or other ferromagnetic material into the coil, called the core, increases the strength of the magnet by magnetizing the core material. Electromagnetic radiation is the form of energy that charged particles absorb and emit. The electromagnetic radiation travels through space with a wave-like behavior. The electromagnetic radiation contains both electric and magnetic field components. These field components oscillate in a wave-like pattern at right angles to each other. This results in the electromagnetic spectrum, which includes radio waves, microwave, infrared, visible light, ultraviolet, X-ray, gamma rays, and cosmic rays. Each type is distinguished by its wavelength. In conclusion, electromagnetism is one of the four fundamental forces of nature. Electromagnetism literally holds things together. Electromagnetism literally lights the world.